Okay, I assume it works. So hello everyone. In case it works, I'm just testing this with the OBS software, so I'm not sure how exactly this looks like. I'm testing on my iPad what I see here, and I'm sorry for not announcing this live before. I just didn't want to announce in case it didn't work. I wonder if you can, if I see some of you are watching, if you can ask questions on the live chat on YouTube. Okay, so now I see that this is working on my iPad. Cool. The live chat is not working. I wonder what's the case with the live chat problem. And my plan is to cover 3 topics and maybe talk for around 30 minutes. Answering your questions if there will be any about so the 3 topics I'm going to talk about is single page apps complexity, microservice versus monoliths, and the third one is code comments, which is more about documentation actually. So I wanted to present my opinion on those topics. Let me know in the comments whether the live streaming is working, whether my network connection seems to be okay. The recording will be available in assuming that the quality is good enough. I'm still playing with experimenting with the software, so it might be changing a bit. So I don't know if my connection, if this is good enough. Anyway, I will start. In case everything is good, I will start. In the worst case, I'll repeat it offline or try to do another live. So my first topic is around, I have some notes here, single page applications and the complexity which it involves. And just for those of you who don't know, my name is Andrzej Krzywda. I'm the CEO of README. I'm a programmer. I've been programming for 20 years. I'm usually trying new things very often, and I'm mostly connected to the Ruby on Rails community. So if you're doing Ruby, there's a chance you may have heard about README or my name. I've started experimenting with single page applications very early. It was somewhere like 2011. I remember when I was teaching Ruby on Rails to students at the University of Wrocław, I said it was 2010. They were really smart students, and I said that very, very soon we will see a strong separation between backend and frontend, and that frontend will just use some JSON to generate to receive the data. And in 2010, it was still a very shocking and controversial opinion, but it was actually one of my predictions which worked. Many of my predictions don't work, and the prediction worked much faster than I expected, I think. And very, very quickly, we've had a situation where the frontend was totally separated from the backend. I think initially it was with the Angular framework. There were other frameworks. Now it's more like with React or Vue. What I didn't predict, so I thought that architecturally or as the infrastructure architecture, that this is a good idea, this kind of separation, mostly for modularity which it brings. What I think I didn't realize back then, and now it kind of surprised me in the end, was how much it will go into specialization. So before 2010, most of the web programmers could do backends and frontends, and now we seem to see organizations, companies switching to this model of people specializing in either frontends or backends. And this is interesting. It's hard to be opinionated in this area because on the frontend part itself, there's so much you need to learn that it's hard to be an expert. And if you want to be an expert in frontend and backend, it's close to impossible. And I see the reason why companies switch to this model of specialization. I think it scales better. You can replace people more easily. For some parts of the front-end work, you can hire juniors. Not all of them, but for some parts of the backend, you can hire juniors. And it's much easier to find people who are good at least one of those. So, but just to bring you this context, I work at README, and at README we try to be full-stack developers. So we mostly do single page applications, maybe not mostly, but we are okay with this choice. But we are not separating our roles, so one person can do the front end and the back end. Obviously, we are not experts on everything, but at least we can finish a feature from the database level to the front end level. And this kind of separation, as I see it in other organizations, brings the situation where one person is not able to finish a feature. And for example, the front-end people are often feel blocked by the backend people, and the other way around, backend people feel like the front-end people, they don't catch up or something like this. The API is working, but they didn't finish the job, or there is a lot of back and forth between them. The API doesn't work as documented, so it's a bit of a problem and a bit of an issue. Another issue was that, and again, what was the situation before single page applications? So in terms of the Ruby on Rails applications, we were just generating HTML on the backend, and then we send the HTML always with full reloads of the website, of the web page, to the front end. Now there are the single page applications approach where you send the JSON. There are some hybrid approaches with turbo links, for example, where you just send some updated pieces of the website. There was this thing called remote JavaScript, RJS, where you just send JavaScript bits. DHH, the charismatic leader of the Ruby on Rails community, he's advocating the idea of sending HTML, but then you have JavaScript sprinkles, as he calls it. So small JavaScript parts, not single page applications, but just parts of JavaScript. So at the beginning, the JavaScript was usually used not that heavily. Over time, there was more stuff, drag and drop, and more like visual stuff. And later on, the data management came in as well. So the data was kept on the JavaScript part as well. And the problem at the technological level is that, for example, we are a Ruby company, but we have to do JavaScript or whatever else we choose, Elm or TypeScript or whatever. So there is a technological mismatch, and you have to switch between two different syntaxes. Today we've had on Fridays we have those weekly technical conversation at README, and today we've had an interesting discussion around like front-end and back-end. And I think we have this kind of discussion, I don't know, every half a year, where we have some new insights, new opinions, in what direction it all goes. Let me just see whether this is working here. Okay, so one of the things I wanted to say was that, and I still don't know what's the right answer, so I'll just share my current brainstorming ideas. Whether the frontend is just a client to the backend, or it's more like two separate applications, the way you think about it, or a new approach where I started to think about it is that there are actually two different versions of one product line. So on the UI level, you are thinking about the same kind of objects, or I don't know what, data as in the backend. It's just there are some differences how you present it, and there are some differences how the code works. So in order to think about it as a product line, the product line means that you have some products here, meaning the software, sharing some kind of maybe core functionality, but they exist in different variations or versions. So they have different functionalities, but there is some common stuff. And I think over time, I'm closer and closer to think that frontend and backend is this situation. We are working on the same product, it's just different versions. So for example, in the frontend stuff, on the frontend part, you usually don't have the real persistence. So it's a version of your application where you don't have the database persistence, while the backend has the Postgres persistence or active record persistence or whatever. While at the backend you don't have the formatting part, how to present the text, nicely formatted to the user. So it's kind of disabled on the backend, it's enabled on the front end. And if you think about it this way, obviously it requires that it should be one technology. So we are probably still in this phase of the technology adoption, where for historical reasons we use different technologies on the backend and the front end. There will be some solutions sooner or later, whether it's WebAssembly or, I don't know, in case of Ruby, we can use Opal, which is the Ruby implementation for the browser. If you're a Python programmer or PHP programmer, there are some other possibilities probably. So I think within 1 decade or 2 decades, we will be much more it would be more normal, and the whole JavaScript ecosystem will normalize as well and stabilize. So thinking about having the same technology on both parts makes it much easier, because then we think about all these features as modules in the code, and we can enable or disable the certain areas of the code. So some concerns are easily separated using just, you just load this module or not. So for example, formatting or persistence. Maybe persistence actually is the one that is harder. So some of the concerns are easily modularized. Some of the concerns are so-called cross-cutting concerns, like persistence, distribution, error handling, and tracing. And this is harder to easily modularize. So this is a topic for probably another live. This is a topic for, I'm now working on a module for the Rails Architect Masterclass, the online class that we have at RKNC for people. And I'm now working on aspect-oriented programming module. So this is more advanced stuff. This is like extension to object-oriented programming on how to deal with those cross-cutting concerns. So I don't see questions or live questions. At least I think I have somehow not enabled the live chat. So I will just carry on and I will gonna start talking about microservices versus monoliths, and just a few ideas. So with the single page applications complexity, I just wanted to summarize this topic. There is currently a complexity because of historical reasons. I think companies deal with it by specialization. I still believe for smaller companies it makes more sense to have full stack people. But obviously both approaches work more or less. It's just, here is less communication around it and the less process is required, I think. And I assume sooner or later we have the same technology. Maybe it's WebAssembly as the virtual machine here for everything, or whether it's the same language as in Ruby versus Ruby, or JavaScript with JavaScript. So that's my current way of thinking about the single page applications complexity, and I kind of regret that this is more complex than it should be right now, but I think we're getting there over time. So the second topic is I will talk about microservices versus monoliths. I'm kind of inspired, maybe inspired is a bad word, but I follow DHH recent runs, and he's often arguing against microservices. And as with single page applications, I was a big advocate at some point. Now I'm more like, I think, maybe not skeptical, but more realistic about it. I'm not against, it's just I see the complexity. With microservices, it's also very hard to be like for or against. I see reasons why microservices might be a good idea in some situations, but probably more often than not, it's better to go with this monolith approach, or as I like the term, modulith. So sometimes we go for microservices because we want to discipline the programmers, we want to discipline ourselves that we're going to have those clear boundaries. This is the part of our application which is the one module is deployed somewhere else on another module, and I don't think this is a good idea for disciplining ourselves. Like, okay, this can work, it's very hard discipline, but I am not sure I like it because it brings complexity again. And it's similar with the single page application complexity, where we have to serialize to JSON, deserialize it, and even just a serialization is still not a solved problem yet. I know there is GraphQL, there's other stuff, but there is still complexity. And the same problem is with microservices. So suddenly your method calls are basically network calls, and this must be slow. You now have to deal with the distributed transactions, so this is difficult. I've been in a project where there were microservices designed from the beginning not in the right way, so the boundaries were wrong, and this was a nightmare. So we've had to merge those microservices at some point to one monolith, but it was a monolith which was once it was in one place, it was easier to modularize. And I like this idea of thinking that optionally I can deploy any of my module as a microservice, but as long as I don't need to, I'm not going to do it. I might need to do it, for example, for performance reasons. So maybe one of my modules requires a stronger machine than the other, and And this might be a good approach, but even though our application is dealing with large amounts of data, the microservices, they don't seem to be the solution for this problem. There are some frameworks for microservices which allow you to work with those modules together locally, for example, and then you just deploy them separately. So I think this is the nice distinction. I would be okay with working with microservices if I have the option of thinking about them as two versions of my application. So again, the product lines idea. So one version of my application is where it's all in memory in one code, in one memory, and then I have another configuration where it's all separated on microservices. So when it's easily possible, then I'm comfortable with working with this kind of situation. But when you have to test it locally by, for example, starting all those processes, even if you have the orchestration needed, you have the whatever is the current hype, Kubernetes or something, even if this is there, if it's just possible to work, you need to deploy those separately. I think it's a big limitation overall and a big complexity. So probably don't have much to add. I think the monolith approach is my current way of thinking. And obviously this requires more than just saying like let's go for modules, because the real art, the real skill is how to create modules. My answer to that is was probably presented in previous videos on YouTube, that we are creating bounded context at the domain level, that we are separating the application layer from the domain layer, and we are creating read models, so we are separating the reads from commands, so queries from commands, and this allows for a nice modularization of most of the stuff. And as I said, I'm now experimenting with aspect-oriented programming for this stuff, which is harder to modularize because it's a cross-cutting concern. So this is my current area of experiments and research. I think which gets me nicely to wrap up this part of the microservices. Even if you watch this video afterwards, after it was live, feel free to add comments or questions if you want to hear my opinion about more detailed questions. And I will now switch to the third topic for today, which is I saw this. So I will be talking about how to document our code, and this was inspired by a tweet from, I don't remember his name. It's one of the guys from Railscore who tweeted about the problem with where to keep the documentation, whether to keep it in the code comments or whether to keep it in Git commit messages. So you see many people which are vocal about not agreeing to having code comments, and I'm actually one of them. Having those two options, I prefer the commit message to let you explain what you did and maybe why you did it this way, and maybe you want to document that there's a hack. However, I agree with this argument claiming that this is archaeology, and then you have to. It's not so easy to review the Git commits for a specific part of the application, why it was done like that. However, I believe that with good IDE, for example, I use RubyMine, so the IntelliJ toolset, and with Git, there's always a way of selecting one file or one module or one directory and just see what were the commits and just review the history. So we have the history of the changes. But I think it's still not perfect. And my solution to this is that when I have modules, I try to have modules in directories. So when I create a Ruby application, I will have a module for a read model. So for a directory for a read model, I will have a directory. So read model is something that you display on the website, and with some code involved for how to keep the data for that. If I have some, ordering bounded context, I will have some files like order and commands related to order, or events like order confirmed. I will have it in the one directory, and then in this directory I will keep a README file, which is a markdown file where I'll document a brief description of what this module is about, so the main building blocks. The second section is usually documenting the technical debt. There's always some kind of technical debt, so it might be just a simple list of points like this part was ugly, and so there's a list of things which are ugly in this module. This is probably the most important part, and the third part is the chronological situation. So it's kind of similar to Git commit messages, where you just document, okay, on this day I have introduced this and this to the module because it was required by this ticket, and I can link the ticket. So those three parts usually are enough for me. The second part about technical debt is mostly important. I see this as important to document where we consider technical debt, not as a way of having a backlog of those things, however it's useful as that, but many times I work with developers and it's not always super clear whether something that I consider a technical debt is a technical debt to another person, to another developer in the team. So having it clearly documented that someone believes this is a technical debt, this is a hack maybe, it's okay, because we don't need to be trying to be diplomatic, or there is no hard communication around that. We just both agree that there is this is a problematic code, and I don't have to discuss whether we want to fix it or not. So once it's in the technical debt section, then we can assume that we want to fix it, right? So that's the agreement kind of. Obviously, when I push a commit to this README file, adding a new technical debt, this might be a good idea for other people in the team to jump in with their comments and saying whether they agree with the concept that this is a technical debt or not. So we can discuss it. Maybe they will convince me that this is not a technical debt. At least the result is either there is a new point in the technical debt, or the point disappears because it's not there, or we can just say, or I can just type in the end, okay, as for me, this is a technical debt. So I'm just saying, according to Andrzej, this is the technical debt, right? So we don't have to have an full agreement. Other people can think about it, and it's just a documentation. So obviously, as with any documentation, there is no easy way to have it in sync, right? So the code may change, the documentation, people may forget about changing the documentation, people are refactoring, they're doing it in rush. So the documentation will always be somehow behind. Now, those three sections, how they can be behind. The first section is the description of the module. So it's mostly about the summary, what the module does, what are the building blocks. And this is easy to, I think, review from time to time and just, update it, kind of have eventual consistency for documentation. So sooner or later, someone will spot that, okay, this is actually now completely different, so we need to change it. The second part is the technical debt, and this is something that also will go out of sync, because one day someone decides that they want to fix a technical debt, one part of it, they will clean this area of the code. So for example, you can say there is this huge method, it's a technical debt, we need to clean it later. And someone does that, but they forget to remove this item from the technical debt. But if we have a habit that whenever you start working on this module, I try to build my habit of reviewing the README file every time I start and every time I end working on this module. And working on a feature usually involves working on 1 or 2 or 3 modules. So I'll just review and see whether it's still there or not. So I have this kind of habit to try to improve. But even with those habits, the documentation will still be slightly out of date. The third part of the README, so the chronology of the situation in this module, this is probably least important. Like, okay, someone didn't add what they did, but this is already a redundancy. We already have git commit messages for this part, so the chronological part can be always easily retrieved. So the README file is kind of like a read model for developers, right? So it's a summary, it shouldn't be like super long. Just a quick overview, okay, usually I need the reminder what are the hacks, because people tend to forget, and I tend to forget what are the hacks in this module. So when I start working this module, I need to go there, because I'm usually assuming optimistically that most of the stuff is fine, I can just use this module and or extend it, but then, oh, this is actually wrong, we have this problem here, and maybe it's better to start with cleaning the technical debt and then later working on this on the feature. And modules are not always features, right? Sometimes you have a module for persistence or for something like that, and it's not really a feature. So between those three options, just to summarize, code comments, I don't like them because they either describe what is happening in the code, so I would extract it to this README file, or there is some number of to-do things, which either is about technical depths or there are actual new features to be added. And most of the time I just don't like the idea that I want to just read the code. I don't want the mix of code and comments. The code is the living thing, so I can help myself with some IDE or with some editor settings where I just hide the comments, but I think the coupling at the file level is not perfect. Obviously code comments, similarly as the README, can go out of date. I think I'm more annoyed when I see out-of-date comments in the code than when it's separated. Git commit messages is another way. Sometimes I see my friends working on some features and the commit messages are almost like blog posts, and it's awesome. I will look at the Git commit messages as well during my work, just to make sure whether I missed something. So I just right click on a directory and see just the commits which are related to this part. So usually there is like no more than, I don't know, 20 or 30. It's easy to quickly review. It's just a couple minutes of work and I know what is happening. But I think this is more like retrieving. This is like joining the data from the Git repository, and the README part, the third option, is to my understanding, this is the best one. Still not perfect, right? So it can go out of sync. I know there's some tooling, or I hope there is some tooling that can actually help you with those README files. So maybe there is a tool for better visualization of this, maybe converting this into a wiki page. Maybe to make it visible at the higher level, what are the modules. So I believe there is some tooling. I've actually don't remember using such tooling, so I think the files are usually enough for my case. Okay, that's enough. Let me know if such lives make sense for you. So this was probably like half an hour, maybe less. And I'm trying to cover like what was recently discussed at README or what's inside my head right now, what I'm working on, and what are the current discussions that are happening. So thanks for watching, and see you in the next video, hopefully. Goodbye, have a nice weekend.